Hello students, welcome to EPG Pathshala. I'm Dr. Manu Sharma from University of Petroleum and Energy Studies. Today we are going to talk on the module Virtual Reality from paper Management Information System. The objectives are to make learning understand about the concept and scope of virtual reality, to understand the applications of virtual reality in business, to understand the future commercial virtual reality based products and services. We adopt the definition of virtual reality proposed by Steuer 1992 because it's a useful technology neutral definition. VR is defined as a real or simulated environment in which a perceiver experiences telepresence. Actually, VR is an advanced form of visualization. It can improve the naturalness of the user interface, possibly increasing the customer satisfaction. Especially the internet environment of most of the ordinary shopping mall is strictly confined by the two-dimensional graphic displays, limiting the naturalness customers can feel in a real shopping environment and possibly degrading the customer satisfaction. VR can be considered as a meaningful technology for complementing the user interfaces in this respect, given by Vaughan and Mon Williams, 1996.
Virtual reality, applying interactive simulations created with computer hardware and software to present users with opportunities to engage in environments that appear and feel similar to real-world objects and events. Three Eyes of virtual reality, which consist of immersion, interaction, and imagination. Immersion includes computer graphics simulation, create a realistic looking world, interactivity, being part of the action on the screen. Interaction includes synthesized word, not static, respond to user inputs, device input, gesture, verbal commands, etc. Imagination includes human imagination, creation of a virtual world, problem-solving application. And the concept was given by Vidya in 1993. Virtual reality continuum, which is on two levels, high and low. High includes desktop, video capture, head-mounted displays, and fully immersive cave and Karen. The levels are managed with three components: presence, cost, and complexity. Virtual reality in product development. Initially, the two models start with the process, that is CAD and FAB model, and it leads to optimization. That is the conversion from parametric to triangle data, reduction of triangles, generation of level of detail. It further leads to digital mockup, that is definition of groups, definition of constraints, adding of simulation, and adding textures as well as adding sounds. And it is further leads to stereo projected tracking, that is CAD, HMD, desktop, and computer graphics rendering imaging. And the last step is the real-time interaction and real 3D, which includes voice control, force feedback, tracking, and real 3D includes distances between objects. Virtual reality techniques, which includes the different types of virtual reality. The first, glasses; second, personal mobile suits; third, head-mounted visors; fourth, tracking; fifth, motion capturing; sixth, fully enclosed systems. History of virtual reality. Morton Hilling told not in computers surround sound idea for the eyes. And the question is why we use 18% of the wearer's field of vision in 2D when we can use 100% in 3D. Sutherland's revolution. Helix machine was equal to cameras, but Sutherland's idea was equal to CRTs, graphics, accelerators, computer-generated images. Virtual reality-based business application. There are a list of applications where virtual reality has contributed, like in military, education, healthcare, fashion, entertainment, heritage, business, engineering, sports, media, scientific visualization, and there are other fields in which AI methods are implemented are as follows: media, telecommunications, construction, scientific visualization, programming languages, and film.
Virtual reality based business applications. Many studies dealing with virtual reality are technical in focus, studying how computer and interface technology can be enhanced from improved human interaction. Little is reported about information system areas where virtual reality can be applied effectively to improve the performance of target information systems. However, Walsh 2001, 2002 and Walsh and Pawlowski 2002 stated that virtual reality could address limitations of web-based e-commerce, expanding the range of e-commerce possibilities. Three important characteristics of virtual reality are immersion, interactivity, and presence, given by Bhatt 2004, Walsh 2002. User interface is defined as an observable two-way exchange of symbols and actions between human and computer in the case of the Internet environment, given by Hartson and Hicks 1989. In other words, user interface usually indicates a computer program or environment that displays options on the screen as icons, that is, picture symbols, by which users enter commands by selecting an icon, given by Gonzalez and Casper 1997. Virtual reality is being used in a number of ways by the business community, which includes virtual tours of a business environment, training of new employees, and a 360-degree view of a product.
Types of virtual reality system. The first, Windows on Word, in short it is called as WOW, also called as desktop virtual reality, using a conventional computer monitor to display the 3D virtual world. The second type is immersive virtual reality, which is completely immerse the user's personal viewpoint inside the virtual 3D world. The user has no visual contact with the physical world, often equipped with a head-mounted display called as HMD. Types of virtual reality system also includes telepresence, a variation of visualizing complete computer-generated worlds. It links remote sensors in the real world with the senses of a human operator. The remote sensors might be located on a robot, useful for performing operations in dangerous environments. Types of VR system includes mixed reality, called as augmented reality, the seamless merging of real space and virtual space. It integrates the computer-generated visual objects into the physical world, which become in a sense an equal part of our natural environment. Distributed virtual reality. It's a simulated world runs on several computers which are connected over network, and the people are able to interact in real time, sharing the same virtual world. Technologies of virtual reality in hardware. First is head-mounted display, called as HMD, a helmet or a face mask providing the visual and auditory displays. It uses LCD or CRT to display stereo images. It may include built-in head tracker and stereo headphones. The another, binocular omni-oriented monitor, called as BOOM in short. Head-coupled stereoscopic display device. It uses CRT to provide high-resolution display. It is very convenient to use. It is fast and accurate built-in tracking. The next technology is Cave Automatic Virtual Environment. In short, it is called as CAVE, Cave. It provides the illusion of immersion by projecting stereo images on the walls and floor of a room-sized cube. A head tracking system continuously adjusts the stereo projection to the current position of the leading viewer. The next technology, data glove, outfitted with sensors on the fingers as well as an overall position or orientation tracking equipment. It enables natural interaction with virtual objects by hand gesture recognition. The technology control devices. It control virtual objects in three dimensions. The technologies of virtual reality in software. Toolkits that includes programming libraries provide function libraries, which includes C and C++. The another technology is authoring systems. It complete programs with graphical interfaces for creating words without resorting to detailed programming. The software packages which are available in the market are Multiverse, Virtual Reality Studio, Sensate Word Toolkit, in short it is called a WTK, and Autodesk Cyberspace Development Kit. Technology of VR software includes virtual reality modeling language. It consists of standard language for interactive simulation within the World Wide Web. It allows to create virtual worlds networked via the internet and hyperlinked with the World Wide Web. Aspects of virtual world display, interaction, and internet working can be specified using VRML, that is Virtual Reality Modeling Language, without being dependent on special gear like HMD. Virtual reality models can be viewed by Netscape or Internet Explorer, that is IE, with a browser plugin. Architecture of virtual reality system. It includes input processor, simulation processor, rendering processor, and word database. Input processor, simulation processor, and rendering processors are linked to word database, and input processor leads to simulation processor, which further leads to rendering processor, and finally the output is attached with the rendering processor. Components of virtual reality system. The first, input processor. It controls the devices used to input information to the computer. The object is to get the coordination of data to the rest of the system with minimal lag time. Keyboard, mouse, 3D position trackers, a voice recognition system, etc. are the example of input processors. The another component is simulation processor. It is the core of a virtual reality system. It takes the user inputs along with any task programmed into the world and determine the actions that will take place in the virtual world.
Here some uses of virtual reality are here. ETS Jack is an example of a commercially available virtual reality software package. It is mainly used for visibility and ergonomics study. There are two of the areas that using virtual reality really benefits. For example, when designing a large mechanical device such as bulldozer or even a car, visibility and ergonomics are very important to the operators. Would you buy a car that was uncomfortable to drive or had poor visibility? Probability not. Many companies spend a large amount of money making their products interface better with the operators. The cost of building prototype is very expensive, upwards of a few $1,000,000 for one machine using the bulldozer example. By using virtual reality, the company could check out the viability and ergonomics of their machine quickly and make changes to it without ever spending money on building hardware. Another area that virtual reality is heavily used in is driving or flying simulations. These provide the users a chance to gain expertise operating a vehicle without the real world consequences of making a mistake. MPI Vega Prime is an example of software package that supports any type of driving simulation. The user builds the virtual environment within the software package. Virtual reality plays an important role in combat training for the military. It allows the recruits to train under a controlled environment where they are respond to different types of combat situations. A fully immersive virtual reality that uses head-mounted display, that is HMD, data suits, data glove, and VR weapon are used to train for combat. This setup allows the training's reset time to be cut down and allows more repetition in a shorter amount of time. The fully immersive training environment allows the soldiers to train through a wide variety of terrains, situations, and scenarios. Virtual reality is also used in flight simulation for the Air Force, where people are trained to be pilots. The simulator would sit on the top of a hydraulic lift system that reacts to the user inputs and events. When the pilot steers the aircraft, the module will turn and tilt accordingly to provide haptic feedback. The flight simulator can range from a fully enclosed module to a series of computer monitors providing the pilot's point of view. The most important reasons on using simulators over learning with a real aircraft are the reduction of transference time between land training and real flight, the safety, economy, and absence of pollution.
Applications of virtual reality. The first, entertainment. It is more vivid, more exciting, and more attractive. In medicines also, practicing and performing surgery on a remote patient, teach new skills. In manufacturing, easy to modify, low cost, and high efficient. In education and training, driving simulators, flight simulators, ship simulators, tank simulators. The basic current problems and future work of virtual reality are as follows: cyber sickness or simulator sickness, low fidelity, expensive, lack of integration between application packages, high fidelity system, cost saving, collaborative, high level contact between participants in distributed network. Some uses of virtual reality. ADS Jack is an example of a commercially available virtual reality software package. It is mainly used for visibility and ergonomics study. These are two types of the areas that using virtual reality benefits. For example, when designing a large mechanical device such as bulldozer or even a car, visibility and ergonomics are very important to the operators. Would you buy a car that was uncomfortable to drive or had poor visibility? Probably not. Many companies spend a large amount of money making their products interface better with the operators. The cost of building prototypes is very expensive, upwards of a few $1,000,000 for one machine using the bulldozer example. By using virtual reality, the company could check out the viability and ergonomics of their machine quickly and make changes to it without ever spending money on building hardware. Another area that virtual reality is heavily used in is driving or flying simulations. These provide the users a chance to gain expertise operating a vehicle without the real-world consequences of making a mistake. MPI Vega Prime is an example of a software package that supports any type of driving simulation. The user builds the virtual environment within the software package. VR plays an important role in combat training for the military. It allows the recruits to train under a controlled environment where they are to respond to different types of combat situations. A fully immersive virtual reality that uses head-mounted display, that is HMD, data suits, data gloves, and VR weapon are used to train for combat. This setup allows the training's reset time to be cut down and allows more repetition in a shorter amount of time. The fully immersive training environment allows soldiers to train through a wide variety of terrains, situations, and scenarios. VR is also used in flight simulation for the Air Force, where people are trained to be pilots. The simulator would sit on top of a hydraulic lift system that reacts to the user inputs and events. When the pilot steers the aircraft, the module would turn and tilt accordingly to provide haptic feedback. The flight simulator can range from a fully enclosed module to a series of computer monitors, providing the pilot's point of view. The most important reason on using simulators over learning with a real aircraft are the reduction of transference time between land training and real flight, the safety, economy, and absence of pollution. Virtual reality head-mounted displays were released for gaming during the early mid-90s. These included the Virtual Boy developed by Nintendo, the eyeglasses developed by Virtual IO, the CyberMax developed by Victormax, and VFX1 headgear developed by Fort Technologies. Other modern examples of narrow virtual reality for gaming include the Wii Remote, the Kinect, and the PlayStation Eye, all of which track and send motion input of the players to the game console somewhat accurately. David M. was the first fine artist to create navigable virtual worlds in the 1970s. His work was done on mainframes at Information International Incorporation, Jet Propulsion Laboratory, and California Institute of Technology. The use of 3D computer-aided design CAD data was limited by 2D monitors and paper printouts until the mid to late 90s, when projectors, 3D tracking, and computer technology enabled a renaissance in the use 3D CAD data in virtual reality environments. With the use of active shutter glasses and multi-surface projection units, immersive engineering was made possible by companies like VRCom and IC.IDO. Virtual reality has been used in automobile, aerospace, and ground transportation original equipment manufacturers in their product engineering and manufacturing engineering. It adds more dimensions to virtual prototyping, product building, assembly, service, performance use cases. This enables engineers from different disciplines to view in their final product. Immersive engineering enables management and investors to see virtual prototypes prior to the availability of any physical prototype. The first use of a VR presentation in a heritage application was in 1994, when a museum visitor interpretation provided an interactive walkthrough of a 3D reconstruction of Dudley Castle in England, as it was in 1550. One of the first recorded uses of virtual reality in architecture was in late 1980s, when the University of North Carolina modeled its Sutherland Hall, home of its computer science department, in a virtual environment. Several companies, including Irisware and Flood Incorporation, provide software or services that allow architectural design firms and various clients in the real estate industry to tour virtual models of proposed building designs. 2010, 3D virtual reality was beginning to be used for urban regeneration, planning, and transportation projects. In 2007, development began on a virtual reality software which took design, coordinate geometry used by land surveyors and civil engineers and incorporated precision spatial information created automatically by the lines and curves typically shown on subdivisional plats and land surveying plans. These precise spatial areas cross-referenced color and texture to an item list. Lowe's, IKEA, and Wayfair and other retailers had developed systems that allow their products to be seen in virtual reality to give consumers a better idea of how the product will fit into their home, or to allow the consumer to get a better look at the screen. The big challenges in the field of virtual reality are developing better tracking systems, finding more natural ways to allow users to interact within a virtual environment, and decreasing the time it takes to build virtual spaces. While there are few tracking system companies that have been around since the earliest days of virtual reality, likewise, there are not many companies that are working on input devices specifically for VR applications. Most VR developers have to rely on and adapt technology originally meant for another discipline, and they have to hope that the company producing the technology stays in the business. As for creating virtual worlds, it can take a long time to create a convincing virtual environment. The more realistic the environment, the longer it takes to make it. It could take a team of programmers more than a year to duplicate a real room accurately in virtual space. Virtual reality technology faces a number of challenges, most of which involve motion sickness and technical matters. Users might become disoriented in a purely virtual environment, causing balance issues. Computer latency might affect the simulation, providing a less than satisfactory end user experience.
So students, let us summarize what we have learned in this module. Visualization of complicated large data is helpful for understanding and analysis. Virtual reality offers us a new way to interact with computer. Virtual reality enables us to experience the virtual world that is impossible in the real world. VR is changing our life. Eventually, VR will increasingly become a part of our life. Thank you.